Hybrid Cloud Show, episode 24. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So I thought we could start with a question that was sent in by Joshua, who's a patron, and sent it into the 2.5 Admins show. But I thought we could talk about it here as well and see if there's any additional opinions we can give from a hybrid cloud perspective. So Joshua says, can you please ask the guys about simple geo-redundancy using VPSs? Currently, our internal tooling is a bunch of Docker containers on a single Linode VPS. We're relying on said tooling more and more, and I'd like a way to have HA and geo-redundancy. Everything I find seems to mention using the Linode load balancers, but that doesn't solve the geo aspect. I don't understand how to have a load balancer that spans data centers. Is there a straightforward and cost-effective way to achieve what I'm after?
The load balancer on Linode by default is geo-redundant. So that does solve your geo-redundant problem. So behind the scenes, I would imagine the Linode load balancer is using something like HA proxy, and it is deployed across multiple Linode data centers, and they're exposing that to you through a set of IPs that probably has BGP or something behind it, or a CNAME record which points to all of the different instances of your load balancer. So by default, that will be 2 or more Linode points of presence that sits in, and then you just need to put your Linode VMs in a private network sitting somewhere behind that load balancer in data centers that it has points of presence in. So that, in theory, does solve your problem. But you said it's internal tooling, so there probably is a little bit more to dig into to work back from what your actual requirement is. Because do you need it to be always on, for example? Could you deal with a 5-minute RTO, 1-day RPO? In which case, actually, you might be better snapshotting the VM, having that replicated off to another Linode data center, and then spinning that back up as a new VM if you were to have an issue in one Linode data center. There's a whole bunch of unanswered questions, but at a very high level, the Linode load balancer is already geo-redundant. So putting instances of that application across multiple VMs behind a Linode node balancer, I think they call it, does solve your problem. But of course, there's a bunch more complexity than that because we don't know what the applications are. We don't know what they're doing about databases, etc., etc.
That's exactly what I was going to go into. A lot of this would depend on are your applications stateful or not. Because if they're stateful, then you have to have some sort of synchronized storage between these different data centers that both data centers could access in real time, or have some sort of like active passive, failover kind of situation. And that would be a lot of work that I don't think we'd really go into. I think if you're trying to do that for stateful applications, you might as well just go Kubernetes. And you can deploy multiple nodes across multiple data centers across whatever your company needs are. So I guess keep it simple. Obviously, you guys like using just Docker containers on a single VPS. That seems to be the trick. So keeping it simple. And I really hope that the redundant load balancer is all you really need in terms of geo-redundancy. But if you need like the data redundancy as well, that's going to be a little more tricky, and it's going to depend on your applications.
I think the other thing to point out here is you didn't mention what kind of geo-redundancy that you're looking for. Say, I'm assuming because it's a bunch of internal applications that multiple availability zones in a Linode region is enough for you. Generally, it is, and I would really advise against trying to go multi-region in any kind of cloud provider, because that adds a whole bunch of cost, complexity, tooling that you'd have to worry about. If you do need to go multi-region, I'm not entirely sure that the Linode load balancer will do what you need. So whatever we say is probably with the assumption that you are just doing multiple data centers within whatever Linode considers a region to be.
Yeah, so generally it might be worth explaining that a little bit, the distinction between the availability zones and the regions of different cloud providers. So broadly speaking, when you have a cloud provider offering availability zones, am I right, you usually have, say, 3 more data centers within a region that are separate enough that you don't normally have the same event taking out all 3 of those data centers, but they are not distant in the sense of being different countries or whatever, like a multi-region setup would be.
I think what you're saying is broadly right. On a simplified level, Aaron, availability zones are what make up regions, and regions are a broader construct where multiple regions would be geographically separate enough to avoid things like power outages, natural disasters, etc. Availability zones within that region won't share things like power, cooling, connectivity. So it is entirely possible to have one or more availability zones impaired without an entire region being unavailable.
What about like something slightly more ghetto and just running like VPSs in different cloud providers in different locations and then using something a little more agnostic like Tailscale to network across them and then just use Cloudflare tunnels? I know it doesn't get around the data part of it, but you could get a very cheap version of like geo-agnostic VPSs running.
You could, because the thing that's always struck me about the Linode load balancer and some of the load balancers in general is that they are quite costly in comparison to just going and running a load balancer yourself or outsourcing that health checking to something like Cloudflare or a DNS provider. Because really what we're talking about here is you wanting to have an instance of that application accessible at any given time and to be able to validate that it's online. And you don't necessarily have the same HA requirements as an active across 3 AZs critical corporate application, I suppose, in this use case.
You covered it a little bit already, Sean, but when I read this question, it jumped out at me that they were using containers on a VM. And I know that's a fairly common pattern, but when you're talking about trying to add HA and geo-redundancy to a bunch of containers, what would be the go-to tools in your toolbox generally?
As soon as you want to go to HA, that's when you need to start thinking Kubernetes. The only other really option there is out there is Swarm, and it's not a great one, and it doesn't address the geo-redundancy that you can do by having multiple nodes in Kubernetes be in different locations. I did like Shane's idea, though, of trying to network these things all together yourself using something like Tailscale, and then, just put an HA proxy load balancer in front of it that you control the DNS for, and problem solved. You can have as many instances as you want, and they'll all just go back to the same HA proxy from anywhere in the world, and then HA proxy will farm it out to whoever's up, and that'll work.
But then you get into the problem of making your own HA proxy geo-redundant. Then you've got to have 2 of those, and then you've got to have something like keep alive D between them to make sure one of them's always online. So you build yourself back into the corner that you're already in of trying to make sure that you've got something that's handling the HA that itself is highly available. And then you fall back into, well, just pay someone to manage high availability of the load balancer for you.
And that's why Google Kubernetes Engine gives you the control plane for free, because they know as soon as they give you that, that's what you really need. And then everything else of that, they're going to get you by nickel and dime.
Do we know if these load balancers like require you to stay in-house in that, like for Linode's load balancer, do you need to only point it at Linode's boxes? Or is there like, they don't know of a cheap, like more vendor agnostic load balancer you could get where you're not managing yourself, but you're also not locked into a particular provider?
So the Linode one is just a TCP load balancer. So I think it can basically accept and forward TCP traffic to anywhere. The disadvantage, I guess, is that it's a TCP load balancer. So I don't know how it works with things like HTTP health checking and response times and checking of content on a page and all that kind of stuff.
Gotcha, but I guess it could work in a pinch.
Actually, so I just looked at the page for the Linode load balancer, and its health monitoring is only on a per Linode health check basis. So it checks if the VM's online and responding, and will forward traffic if the VM is online and responding. So that in itself is quite a big limitation, because if you've got your 3 VMs in 3 separate Linode data centers that are all online and all should have the application running, and one of them doesn't, but the VM's online, the load balancer might still forward traffic to it.
Is it worth taking a second to just zoom out, maybe not just for Joshua's benefit, for everyone else as well, and talking through how load balancers and HA work to give you highly available services in a deployment?
Sure. I can talk to it from a very simple level, but essentially you tend to use load balancers to try route traffic across different services behind that. You would do that when you don't want to have to like nurse a single VPS, which is what Josh is doing right now. So you'd have a set of VPSs or whatever set of services behind the load balancer. And basically the load balancer would do some sort of health check or status check on the boxes behind it and decide where to route traffic. Now, that might be that you want to spread the load across several boxes just because the traffic you've got would max out a single box. Or it might be that you want something that's highly available so that if you lose a box somewhere, that your application is still unaffected because essentially you've got redundancy and the load balancer will see, oh, this box is unhealthy, I will route traffic to the other boxes. Other cloud providers might also do things like detect that your box is down behind a particular load balancer, and it'll try to reprovision the resource but point the traffic to the other services. So say you've got 3 machines behind a load balancer, one goes down, you'll point the traffic at the other 2, and then whatever cloud provider will spin back up a third one to make sure that you retain that highly available set of machines.
Specifically, the limitation here is that the Linode load balancer will only be able to tell if your VM is up or not, and not actually like hit a health endpoint on your application to see its status and then validate that a certain response comes back as appropriate. Because if you did that, then you could farm it out to any cloud or any box with a public IP anywhere. So something to know with this load balancer.
Yeah, there can be a lot of different types of health checks you can do against the services that are behind the load balancer. Typically, it's quite configurable. I'm used to the ones in AWS, which have lots of different options. And yeah, this is quite the limitation.
Equally, it's $10 a month. So it is about the same price as going and deploying 2 Linode VMs in 2 data centers with HA proxy and trying to manage it yourself. So I'm not going to knock it too hard. It probably serves the purpose for the types of workloads that you're going to deploy on Linode for most cases.
I guess you're engineering your application then to basically take out the VM if the app itself is down to try to like filter up the error.
Yeah, it's a bit of a difficult one to solve, isn't it? Because if you're only monitoring, is the server online or not? There are so many variables that could happen between the application crashing and the server just being completely unavailable and failing the cloud provider's health checks.
Yeah, I might have a process on the box that might recover quickly. How do I tell when it's something that's recoverable or not on the box to then know whether to just kill the VM entirely? Or yes, this might be a cheap solution, but it may get expensive in your time.
Yeah, if you can reprovision the VM, right? It might have stateful data on the disk that needs to persist. You can't just reprovision that.
Yeah, then you're in big trouble.
Yeah.
So I just want to come back a second because, again, I'm kind of fixating on the fact we're talking about sticking these containers on VMs, and then we've talked about the problems with that in terms of health checks, etc. So what would you guys actually do if you were deploying this in one of the clouds you knew well?
So I think even if I was deploying this in Linode, I'd probably use their really simple Kubernetes offering that they have. So they have something called LKE, which is Linode Kubernetes Engine, which gives you this HA and load balancing stuff as part of it. It's probably going to be more expensive than your current 1 VM setup. So, for example, a 2-node pool with 4 gig of RAM and some dedicated CPU is going to cost you about $36 a month. And then I think there is some control plane cost on top of that. So that is something to bear in mind. Equally, if you want the HA control plane, which it sounds like you probably do, that's another $60 a month. So a way more expensive solution than your 2 VMs and a load balancer. However, it is going to give you that state engine that Kubernetes is. So you can say, hey, I want 3 copies of this container running, and go figure it out and do the load balancing for me, Kubernetes. And it will do that. I don't know how many applications that Josh has, but if it's more than maybe 5 applications that you're having to run and manage across multiple boxes, maybe it's something that's worth looking into just for the time savings alone.
It looks like Akamai does have their Akamai app platform, which is just an extension of Linode Kubernetes Engine. Just gives you a more like simplified view. I guess you can just have like the 1 container or 2 that you need. And Amazon, it's called ECS, the Elastic Container Service. That seems to be exactly what you need, right? You can just deploy your application as a container and have it run and be managed for you without having to manage the underlying hardware. But like Gary said, that convenience comes at a cost.
$132 a month, to be precise, for the 3 4-gig 2 CPU nodes and the HA control plane. So not cheap.
Not bad.
Also not bad, yeah. How much is your time worth in terms of managing these across multiple VMs and making sure that you're directing traffic to the right one and everything else?
You don't get many engineering hours for that, do you?
No.
This episode is sponsored by SysCloud. Companies big and small rely a lot on SaaS applications to run their business. But what happens when critical SaaS data is lost due to human errors, accidental deletions, or ransomware attacks? That's where SysCloud comes in. It's a single pane of glass to back up all critical SaaS applications such as Microsoft 365, Google Workspace, Salesforce, Slack, HubSpot, QuickBooks Online, to name a few. SysCloud also helps with ransomware recovery, identifies compliance gaps in your SaaS data, monitors for unusual data activity, and can automatically archive inactive SaaS data to save on storage costs. Plus, it's SOC 2 certified, so data remains secure in the cloud. Over 2,000 IT admins already trust SysCloud to protect their SaaS data. Head to syscloud.com for a 30-day free trial. And, for a limited time, use code HCS to get 50% off your first purchase. That's syscloud.com. So we've had some great feedback and some good questions. Now, some of those we have come back and answered directly by email, so check your inboxes for those. One of the questions we had was from Evangelos, and they ask, effectively, it's a fairly long email, so I'll try and summarize it as well as I can, that they have about 5 terabytes of storage that they need to have somewhere. And the idea is to have that in the cloud, the public cloud, but to have local access to about 2 to 3 gig of that that they have accessed recently. And they're asking what kinds of architectures would make sense to do that. They did specifically call out AWS Storage Gateway as a please do not suggest that. So I'm guessing that's probably going to be the first thing that everyone suggests.
Though reading this email actually reminded me of a really sweet hybrid cloud solution I had many years ago, which was I had at a small startup, we had a box that just sat in the corner running Samba. And then suddenly we were quite successful and we needed to scale up and we needed a second office. So now, oh no, the Samba box won't work. So I just put a second box in the new office, put Samba on it, and then just used Dropbox for the two of them and just had Dropbox syncing between the two servers and then Samba basically serving out. Like basically it was getting around Dropbox's user limits essentially. But yeah, there you go. So there's my sweet, slick 2010 solution to that problem.
I mean, I have a productized solution for that with Google Drive and the Synology sync service where that's shared out as a Samba share and then gets synced down to NAS in multiple locations. I guess the source of truth is always Google Drive. So if I wanted to go back to it, I can still access it through the web console, but not the nice cloud-first solution, or I guess public cloud-first solution that maybe Evangelos was looking for here. You're right, Aaron, in that Storage Gateway was my first thought here. And Evangelos says, for reasons, please don't suggest it, but doesn't really go into what those reasons are. I'd be really interested to hear those, because as far as I'm concerned, it is a pretty good solution and does work pretty well and it's cost effective. So I suppose what you're really looking into is, do you go and re-implement what Storage Gateway does yourself? You mentioned using something like rclone with some caching or MinIO with caching and then serving those out via Samba or NFS or something. You could do that, but you're going to end up being the person on the hook when that breaks, because it won't be an if, it will definitely be a when, in my opinion. Or you're looking for some kind of open source alternative. So one I came across was called the Versity S3 Gateway, which is an open source S3 gateway from a company called Versity that interfaces with anything that is S3 compatible. So that might be S3, it might be Backblaze, it might be something like MinIO. That could work really well for you. I haven't personally tried it, but it effectively translates the S3 API requests and allows you to present those out through something POSIX compatible. So they just show up as a file system on your Linux box, and then I guess you can do whatever you want to with that. So that would be one option. I'm sure there are a bunch of other tools that exist in that space, but this seemed to be the most popular one that I'd come across that did similar things to S3 Storage Gateway.
Perhaps a stupid question, but why would you only have the 2 to 4 gig of just read files locally rather than just having the 5 terabytes of it locally as well as in the cloud? Like 5 terabytes of local storage isn't exactly expensive.
This was another thing I'd thought about, right? Because if we were talking 50 terabytes, it would be an entirely different conversation. But you're right, having a couple of 8 terabyte disks in a mirror would more than serve your current and future expansion needs, and you could still back those up to Backblaze in the way that you're currently doing. And it's not super expensive, so it would be interesting to see what the specific reasoning is behind it. You say you've got lots of small files that are changing frequently. You're right, Aaron. To me, that lends itself really nicely to having on-prem with like maybe hourly or daily backups to Backblaze or something, because if not, you're going to be really hammered by your public cloud provider in terms of put and get requests for every single one of those small files that changes.
Gary, you just hit on the thing that I was going to call out, which is, yeah, you could do this with like Backblaze or B2 or S3 or whatever, but you're going to get slammed in your limits. And like some, B2 is usually more gratuitous than the other clouds, but every fetch request you get, every ingress or egress, all of it, you have to pay for. And so it might not be too much if you're trying to just send stuff up as a delta, but if you're trying to send S3 files, which are very, small files individually, that's going to take a long time. And that might suck up some bandwidth that maybe you need for on-prem stuff. As well as if you ever have a failure and you need to get all that 5 terabytes back for whatever reason, that's going to be expensive to get. Versus if you already had that 8 terabyte disk in a mirror and one of them fails, well, then you have the other one and it's no problem. Or if you need to rebuild from scratch, it's again very quick, as fast as your LAN provides. I think that's the way to go.
Particularly with the like storage tiers in AWS, you might pick a cheap option now because running it's cheap, but then you're right, the egress costs go way up again if you're using Glacier or something else, and things get real pricey, surprising prices at the wrong time.
Yep.
I think the other thing to mention here is that you said you were looking to move to a cloud solution, but if you're still presenting that back from on-prem, that doesn't necessarily give any advantages to your users who aren't on-prem, right? They're still going to have to come into the VM that's on-prem, access the files via your Samba or NFS share or whatever else. So it doesn't really gain them anything either in this particular use case, as far as I'm reading it.
Well, I think that just about takes us to the end. But before we go, I just want to say thank you to our existing PayPal supporters and patrons. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon, you can get an ad-free feed of either just this show or all the Late Night Linux family shows. And sometimes you receive episodes early. If you have any questions or feedback, you can send those to show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.